Don't overthink, don't stress out, just read it. What's it about? Fencing. Might all you got in there, maybe area. Okay, let's pick out. So 40 meters of fencing is going to be important. The shape is going to be important. So which dimensions tells you what you want. Give me a synonym for largest. Give me another synonym. Greatest. Give me another synonym. Maximum. Write that in brackets. It's a fancy way of saying find the max. Just put your pens down and watch. I'm going to go off on one of those tangents when I explain why that you really don't need to know, but I really like telling you the why. If we need to make a rectangle, and we've got 40 meters of fencing, our first possibility is if I make the width equal to 1, what would the length be? So I have only a 40 to go around. How much have I already used? I've used 2. I've got how much left? And I have 2 sides. So it has to be 19 and 19. So let's just double check. 19 plus 1, 20 plus 19 plus 1, 40. So what would the area of this be? 19 meters squared. Okay, next possibility is I could make the width 2, which makes the other width 2. 18. Let's just double check. 18 plus 2. And 18 plus 2, 20. Okay, so that area would be 2 times 18, which is? So which of these two possibilities has the largest area? The second. So I could keep going with all the possibilities. So what I did was just set up a spreadsheet before you came in rather than actually write them all out. So length of 1, I calculated this just by taking 40 minus twice the 1 and then dividing it by 2. So here's all the possibilities that we could draw out if we wanted to. So there are, in theory, 19 different possibilities. Okay, so this isn't a big deal. Why can't we just do it using this? So area I can just do using a formula. So area is going to be length times, but not what I wanted. Okay, so there's our 19. If I fill it down, those are the areas. Okay, so take a look at the numbers. They're going up, 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 up. Uh-oh. What starts happening here? Down, 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 down. So what's the largest area? 100. So what's the dimensions that are going to give us the largest area? Okay, so the reason this is in this unit, I'm just going to highlight these 2 rows, and I'm going to graph them. What shape did that make? That's why it's in this unit. So could we do this question with guess and check? Absolutely. But what if I told you there was 4,000 meters of fencing? Well, how many different possibilities are there going to be? A lot. Would you want to have to write them all out and check them all? No. So that's why we have the process we're about to do, which is called MaxVid, is because, yeah, a simple number, guess and check, no big deal, but a bigger number, we don't want to. These are always going to work the exact same way. The first example, maybe even the second example, you're going to feel really oogie because it's something different you've never seen before. After we've done all 3 examples, you're going to see they're exactly the same every single time. The numbers are just going to change. So bear with me. I'm going to draw a rectangle because the shape is a rectangle. I need to assign a variable to either the length or width. It's completely our choice. I'm going to call the width x for no other reason than I just really like the width. The problem now is I can't assign a different variable for the length because then I'm going to have 2 different variables to work with, and we don't like that. So what I'm going to do is assign an expression for the other 2 terms using what I know with the 40 meters. So in general, I know that 2 w's, 2 widths, plus 2 l's equals 40. True statement? Okay. I've called the width x, so I'm going to put x in there. And I could have called it w. I could have called it anything. We're just used to seeing a parabola with x. That's why I tend to like x. And what I want to do is just get this L by itself. So I want to get rid of all the numbers, get the L by itself. So how do I get rid of an addition of 2x? Subtract 2x. How do I get rid of the coefficient of 2? And if I divide one side by 2, I have to divide the other side, and I want to divide both those pieces by 2. Kind of mumbled through his hoodie, 20 minus x. So instead of calling this L or calling it Y or calling it another variable, all I'm going to do is call it that expression, which is 20 minus x. The reason I've done that is because I only have one variable to deal with. I don't have an x and a y, I just have an x now. Still with me? Yes, no, still with me? Okay. What I'm looking to do is maximize the area. So I need an expression for an area. So I'm just going back to grade 7. Area of a rectangle is length times width. And all I'm going to do is stick in the expressions that we have. What have we called the length? 20 minus x. What have we called the width? X. Don't like those brackets. Mathematicians, we try to get rid of brackets, so I'm just going to distribute. If you need to move the x to the front for your brain to see it's a distribution, then do that. If your brain's fine with it being in the back, put it in the back. So x times 20. And x times negative x. What kind of equation is that? Quadratic, and that's why we're doing it in this unit. So all I'm going to do is put that x squared first, because we're used to seeing a negative x squared and then a plus 20x. So that's just a regular old parabola. What are we trying to find? We're trying to maximize or minimize the area. So this is the same thing if I said find the maximum of this parabola. How do we find a max? This is there. We can just pick a max off like that? Is that the max? No, that's the direction. Is this in the right form to just look at it and get the max? No. So what form do we need to put it into? Vertex form. And how do we get into vertex form? Complete the square. So this is just now a completing the square question. If your brain doesn't like this a, feel free to call it y, because it's what we're used to seeing parabolas as y equals something. If your brain doesn't care about a, don't worry about a. It's just a variable. It's meaningless. Don't get caught up in what's on the left-hand side. Okay, completing the square. Good time to review. First thing we check is there a coefficient on x squared? Okay, what's the coefficient on x squared? So I got to take it out front. Negative x squared divided by negative 1. 20x divided by negative 1. If I had a third number, like sometimes we do, what do I do with it? Just put it on the outside, leave it alone. I just don't worry about it. We just happen to have 0 in this case. How do I fill in this space here? Complete the square, which is middle divided by 2 squared. So 20 divided by 2, 10 squared plus 100. How do I balance out adding 100? Subtract 100, except what do I have to multiply by? The minus 1 in front. Still with me? Again, a, y, I don't care what's on the left-hand side. Use whatever your brain likes better. So I'm just going to put a negative instead of negative 1 because we understand we don't need the 1. I need some kind of binomial squared. Offer of x minus 10. Xander, where'd that come from?
Two numbers that times equal 100.
High five. What do I do at the back here? Just simplify it. So negative 100 times negative 1 plus 100. State the vertex. Grab them in the red pen. With these questions, the vertex will always be this. This is whatever you called x. And what did we define as x at the beginning of this question? Come all the way back to the diagram. What did we call x? The width. So this is the width. We could have chosen to call the length x and then gone from there. We just happened to call it the width. The second value will always be your max area. And now it just depends on the question what you're answering. Sometimes the question will say, what is the maximum area? Sometimes it'll say, what are the dimensions? Sometimes it'll say both. So just depending on what the question asks us is how we're going to answer. What did this particular question want to know? What are the dimensions that will yield the maximum area? It actually didn't ask for the area, it wants the dimensions. So we need to give a length and we need to give a width. Do we already have one of those? Yes, so the width we know is And give me some units on that. Meters. What about the length? Well, the length is going to come from this expression we had right up here. So what do I know about the value of x? It's 10. What's 20 minus x? 10. What did our spreadsheet say were the best dimensions to get the largest area? 10 by 10. How are we feeling? No squared areas in this one. This is step number 1. Draw your diagram, assign variables. So you can call length x, you can call width s. It's completely up to you. I always do width. I don't know why. It's just the way my brain works. Step 2 is you're going to use an expression for the perimeter, because that's really what this is, to isolate the other variable. Step 3 is finding an expression for the area. And really down to here, I've just simplified it. Step 4 is completing the square. And the last step is just getting the vertex and answering the question. I know these are long. I know they look scary. You're going to see as we move through the next 2 examples, they're almost identical. We're just going to change the question and change the numbers. Okay, number 2. Lots of words in there. Read to read. What's it about? Fencing, and you might have got chickens. That's all you need on the first pass through. Now let's dissect it. The first sentence, what do we need to know? Mathematicians, do we care that it's for chickens? No, we don't care if it's for horses, chickens, cows, whatever. It's the farmers that care about that. Second sentence. Barn one side. So already we're changing the situation a little bit from the first example. The first example, we had to fence all 4 sides. How many sides are we going to have to fence in this one? Just 3. Okay. The last question or last sentence? I want you purposely to start a new page because I want you to keep this example beside it. And you're going to see we're going to do it step by step, and it's going to look almost identical. The numbers are just going to change. Max min problems are paper wasters. I'm sorry. Oh, because you're going to know, oh, and it's on the wrong page. Oh, wrong page. I'm going to draw the diagram a little bit differently. I'm going to draw what's called a bird's eye view. So imagine we're on top looking down. So if we saw a barn from an airplane, what would it look like? Square, rectangle, we don't know, we don't care. Here's the barn. Is the pen for the chickens outside or inside? We assume outside because why would you fence inside a barn? So here's pen. But do they use fencing or do they use planks? Fencing inside a barn? I don't know, fencing inside a barn. I don't know. So this is why I'm not a farmer.
It'll be like to separate like the chickens.
Yeah, but usually it's just like slats. Like it's not like. Really? Chicken wire inside the barn. This is why I don't farm. Yeah, this is why. Let's assume it's outside. Right now, what's the only difference between these 2 questions? The number of sides. That's all that's different so far. Pick something and call it x. I usually go with the width, but it doesn't matter. You can call it the length. The perimeter, this is going to be 2 lengths, or 2 widths, sorry, plus 1 length equals 80. The only difference so far is we don't have 2 lengths, and instead of 40, we have 80. We still want to isolate this cell. We want to get them all by itself. So how do I get rid of 2w? Oh, sorry, I want to put in x first because I called it x. And if you want to leave it as w, you can leave it as w. It's just sometimes later on when we're trying to complete the square with w, it throws off some brains. That's why I use x. Now, how do we get rid of the 2x? Step 3, we're trying to maximize area, so we need area of a rectangle, which is just length times width. What's our expression for the length? And what's our expression for the width? And again, don't get too caught up in the variables. If you want to keep it in W, that's fine. It's just usually for parabolas we're used to seeing X. Okay, look back at the last example. The numbers are different, but the steps are the same. What did we do in the last example? We distribute that X. So again, if you don't like it at the back, you can move it to the front, whatever works best for your brain. 80 times X, negative 2X times X. Again, peek back at the last example. The numbers are different, but the process is the same. What did we do in the last example? Yes, there was a step just before that. Step still just before that. Yeah, we put it in the correct order. We put the x squared first because we need it to be in parabolic form. So minus 2x squared plus 80x. Okay, now we're into complete the square mode, so you can actually forget everything about length and widths and bar and everything else. Just look at this like a parabola. This is just regular complete the square. Is there a coefficient on the x squared? So what do we need to do? Take it out front. Negative 2x squared divided by negative 2. 80x divided by negative 2. And then I'm going to leave that space that we're going to fill in a second. Okay, now we're filling in the space by completing the square. So middle divided by 2 squared. So 40 divided by 2. 20. 20 squared. Do 2 squared, then add the zeros. How do I balance off plus 400? But I have to multiply by negative 2. Now I'm just finishing off completing the square, leaving the negative 2 in front. I need a binomial squared. Offer of x minus 20. Now I just need to clean this up, simplify negative 400 times negative 2. Vertex. At this point, can either of those values be negative? Why can neither one of these values be negative in this situation? Because they're length and area. So you might want to make a note. If you get a negative in this spot, you've done something wrong. And usually it's this factoring of the negative 2 as you've missed changing the negative 40 and carried it through. So in the dimension problems, the vertex and, well, the vertex in total is always going to be positive. Okay, so if you've got a negative here, you've done something wrong somewhere. Last part is just answering the question. What does this question want to know? What are the dimensions? It actually didn't even ask for the area. It doesn't care. It needs to be the length and the width. What is this 20? It's the width because we chose to call the x width. So the width is 20. How do I get the length? Yep, just go right back up, step above. $80 minus 2 times 20. We do the multiplication first. So 80 minus 40 is some units. Could we have done it with the spreadsheet and guess and check? Absolutely. But this will work for any kind of numbers, and it doesn't matter how big the numbers are. Put the questions side by side. Can you see a similarity? Okay. All the questions that are dimensions are going to work like this. Just the number of sides is going to change, and the amount of fencing is going to change, or the amount of siding that we have. How are we feeling? Okay, number 3 is the longest one. Up to you at this point. Okay, just read to read. Don't overthink. Don't stress. What's it about?
That's being divided into
And maybe you got to that middle sentence and kind of went, I don't know what's going on here, and skipped over it. And that's okay. That's okay in the first read through that you don't catch everything. Okay, first sentence. Now, in your world, they're always going to be rectangles. When you get into grade 12, they won't be. That's why we keep saying rectangular pen, rectangular pen. And what is parallel to two sides? Okay, last sentence. Why haven't any of these questions asked about minimize? Why are they all maximize, maximize, maximize? You don't want a small pen. Plus, you know the dimensions that'll make it the smallest. It's got to be 0 by 600. And 0 by 600, what's the area? 0. So that just doesn't make sense in terms of fencing. If you want to do a separate page and still have the first example next to you, completely up to you. It doesn't matter. Step 1. What did we do first the last 2 times? What does this middle sentence have to do with what's going on? Well, he divided this in 2 by putting up another fence parallel to one of the sides. Does it say if it's parallel to the width or to the length? Doesn't matter, it's your choice. Would you like to put a vertical division or a horizontal division? Does it have to be exactly in half? Does he say he divided it in half? It could be anywhere we want it to be. It could have been in half. It could have been horizontal. It's completely up to you. It's not going to change the question. What that has done is given us how many sides to fence? 5. So the first question had 4 sides because it was just a regular rectangle. The second question had 3 sides because we used his barn. This one has 5. That's all we're doing is adding more sides. Let's call something x. What would you like to call x? So this is x, this is x, this is x. We got to figure out what the other thing is in terms of x. So we know that 3x plus 2l's has to be 600. And we're assuming we use all the fencing, that there's none left over. What are we trying to isolate here? L. How do we get rid of 3x? How do we get rid of the 2? What the heck am I supposed to do with negative 3 divided by 2? So we can leave it as a fraction. We can put a decimal, do whatever makes your brain happy. And 600 divided by 2? Whew, that one divides evenly. So that means our length up here is negative 3 halves x plus 300. Okay, peek at the last 2 examples. It's going to look exactly like this, just different numbers. What did we do next at this point? Area. Still length times width, even though we have an extra side, doesn't matter. What's our expression for the length? And our expression for the width? What did we do the last 2 examples at this part? Complete the square. This would be a calculator question. We wouldn't expect you to complete the square by hand with a coefficient of negative 3 halves. So what I'm going to do, because we're going to use our calc, is just turn it into a decimal. Is there coefficient in front of the x squared? Okay, so we need to bring it out front. And this is where you probably want to grab your calc and do 300 divided by negative 1.5. You hungry? Were you left-brained or right-brained, Ethan? You don't remember? Pen chewers are usually right. Sorry? Offer of negative 200. Okay, leaving a space. Middle divide by 2 squared. How do we balance off adding 10,000? But what do we have to multiply by? Yeah, it is a lot of space. Well, maybe he has a chicken farm that he's selling them for chicken parts. Maybe they're eggs. Maybe it's an egg farm. You're letting the big number scare you. Don't overthink. What's the relationship? Minus 100, middle divide by 2. Okay, simplify this guy up. I heard a little mumble of 15,000. Confirmation. Vertex. We do a little check. Are they negative? That's good. Do you see the difference between what would be a max-min calculator question and a non-calc question? Okay, so one, for example, we didn't need a calc. Numbers were small enough. This crazy one, we used a calculator. Are we done? Nope, we need to actually answer the question. What is it asking for? What's the width? How do we find the length? Right into there. Offer of 150. Are we done the question? There's the answers. Done. Julie. 10,000 here. Who can tell her where 10,000 came from? Middle divide by 2 squared. Other questions? We're good. I'm thinking we should stop, do number and profit tomorrow. Do you want to wait on the homework questions, or do you want one or two to practice like yesterday?